So this is the fifth and final video in our series on quadratics, and what we're going to do in this video is take all the bits and pieces we've been looking at previously and bring it all together in terms of how we would go about sketching a quadratic curve. And the one new bit we're going to look at, which is our bottom bullet point there, is how we can use completed square form to find what we call the vertex of a quadratic curve. So here we go. If we're going to sketch a curve, it's got a certain number of key features that we need to identify and that the exam question will be very specific about asking you for. The first of those would be the y-intercept, which is where the curve cuts through the y-axis, and as same as with our y equals mx plus c, the y-intercept is always just the constant term in the equation. The reason that's happening is because it happens when the x-coordinate is 0. So if you think about a quadratic curve, you've got x squared, that would be 0 squared. You've then got an x term, again you times by 0, so you're just left with the number on the end. So the c is still just the y-intercept. That's the straightforward one to do. The one that requires a bit more work are the x-intercepts, and as we've seen previously, this is when the y-coordinate is 0. So what we're going to do is set our equation equal to 0 and find the roots of the equation. And we've discussed previously how many roots a particular curve will have is determined by the discriminant. In this particular diagram, clearly we've got two distinct roots, so we'd know that b squared minus 4ac would be greater than 0. But obviously that is not always the case, as we've discussed previously. Next one is the turning point. Now the turning point is what we refer to as the vertex, almost like the corner of the curve. In this particular case, it's a minimum, because if you consider all the possible y values, I'm getting smaller and smaller in terms of the y coordinate, and I get to this point here where it starts going back up again. So at the point there at that vertex, the y coordinate is as small as I can make it and still be on the curve. So that would be referred to as a minimum. And obviously if the curve was flipped upside down, if it was a negative quadratic, we'd be talking about a maximum point. And we can use completed square form to find the exact coordinates of that point, and that's something we'll have a look at in a couple of slides' time. The final thing we're going to look at is the line of symmetry, which is that bit's obviously straight down the middle, and that is always going to be written in the form x equals, because obviously a vertical straight line like that is always going to have an equation x equals. And clearly we need to be very, we need to note that it's exactly halfway in between our two roots, and that's something that we need to think about when we start sketching the curve, because it will be important to make sure that you get your minimum point appearing in the right part of the graph. And again, more about that later on. So let's have a look. We've got a curve here, y equals x squared minus 7x minus 18, and we've got to sketch it. Now let's be very clear, a sketch does not mean you're going to start calculating points and plotting them precisely. That would be a plot. A sketch is just kind of a freehand drawing, and then what you do is put on information to indicate the key points. And the key points that we're being asked for here are the points where the curve meet the axes, so we're going to need the x and the y-intercepts. It's asking for the coordinates of the minimum point and the line of symmetry. So there we go. There's a blank set of axes to start off with, and we're going to go through and we're going to figure out all the bits of information that we need to put on here. So first of all, it's going to meet the it's going to meet the y-axis at minus 18 when x is 0. See, that's just the number on the end. When the y-coordinate is 0, that's going to give us our x-intercept, so we're going to get our equation there. Solve that, and so we've got x values of minus 2 and 9. And so now what we've got is points where the curve is going to go through, so we can draw the curve through. But the one thing I'm going to think about before I draw it is the fact that if I've got points, it's going to the axis at minus 2 there and 9 there, that means the minimum point, which is halfway between those 2 points, has got to be somewhere here. So that means the curve is going to come down, go through minus 18 and keep going down into this quadrant before coming back up again. It's absolutely vital that we make sure it's clear on our diagram that that minimum point is going to be below minus 18 and it's going to be somewhere in this quadrant. So let's draw the curve through. There it goes. And so there's the sketch of my curve. So I've done part A, I've drawn the sketch, I've put the points on where the curve meet the axes. Now what I need is the coordinates of the minimum point. So to do that, we're going to need completed square form. So let's take our equation, write it in completed square form. So I've got half of the x coefficient, so that's x minus 7 over 2. That's going to give me x squared minus 7x. I'm going to get the bit on the end that I don't need, which is going to be 49 over 4, so I'm going to get rid of that. And then the minus 18, and then just put those two bits together. So there we go, we've got our equation written in completed square form. Now, the reason this is important, the reason this works is if we consider where the minimum point is going to be, which we know is here, the smallest we're going to get, or the smallest possible y value we're going to get, is going to come from when this part here is minimized. We know that this section here that's now highlighted in yellow is a squared. We know if we square anything, it's going to become positive, so the smallest we can possibly make that, or the smallest value that can possibly have, is a 0. If it's anything else, it'll be squared. With a positive note, it'll be squared, it'll become positive, it will be higher. So we've got to make that 0, so we've got to pick a value of x that makes that bracket 0, and clearly the value of x that we're going to choose is going to be positive 7 over 2. So if I now have x is 7 over 2, I've got 7 over 2 minus 7 over 2, that's 0. 0 squared is 0. And what that leaves us with, the y coordinate, is 0 minus 121 over 4. So when x is 7 over 2, y is going to have a value of minus 121 over 4. So what that tells us is, at that x value, the y coordinate is that one. And so our minimum point is there, and there's the coordinate 7 over 2 minus 121 over 4. So that's part B sorted. Part C, fairly straightforward. I know that my line of symmetry is going to go through that minimum point. It's going to go through my vertex, and so that's going to have the equation x equals 7 over 2. So there's my diagram, and I've done all parts A, B and C, and I've put all the information onto my sketch. Now, this last slide is an exam style question. This is the kind of thing that you might be up against, so bringing together lots of bits and pieces. So we've got to first of all do a bit of completed square, then we've got to calculate a discriminant, and then we've got to apply what we understand from parts A and B to our sketch. So here we go. First of all, completed square. The problem with this is the fact I've got a minus here. So what I'm going to do is factorize. I'm just going to take a minus out of the front. There we go. So first thing is I kind of reordered them because I always like to have my x squared first, then take out a minus. So I've got minus x squared minus minus 4x, gives me plus 4x. And so I've taken the minus out of those bits, and just there's my minus 5 still sitting on the end. I haven't done anything with that bit just yet, so that's still minus 5. So now I'm going to do complete square on the bit in the middle here. There it goes. Half of 4 is 2, so I've got x minus 2 all squared, and then take off the 4, which comes from the 2 times 2. Now multiply out the bracket, so I've got minus x minus 2 all squared, minus minus x plus 4, and there's the minus 5, and then finally tidy up those two terms at the end. So I've got minus x minus 2 all squared minus 1. So what the question really is asking for is here, I've got to take this expression and write it in that form. So if you see a question like this, don't start trying to multiply out brackets here and start trying to solve things. This is just a way of saying, take this, write it in completed square form. So now you can see that my value of P is going to be the value inside the bracket. It's going to be minus 2. My value of Q is going to be minus 1. So there we go. Part B, we've got to calculate the discriminant, b squared minus 4ac. And again, don't get caught out because the way this equation is written is not in the order that you normally get. So we've got A is going to be minus 1, there's B, which is going to be 4, and there's C, which is going to be minus 5. Always a good idea to write those values down on your paper so you kind of just doing that thinking carefully before you start plugging them into the equation. So we've got 4 squared minus 4 times minus 1 times minus 5, so that gives us 16. Now here we've got minus 1 times minus 5, minus times a minus makes a plus, so I've got 4 times a positive, so I've still got a minus there. And so that gives me minus 4. Now, it says just to calculate the discriminant. It doesn't say I've got to do anything else with it, but straight away I'm thinking, okay, when I get to part C, I know that this equation because the discriminant is less than 0, I know this thing is going to have no roots. So I'm thinking about that already before we get on to part C. And I'm going to use what I know from parts A and part B to help me with the sketch. Okay, so here comes the sketch. Off we go. We know that in completed square form it looks like that. So first of all, I'm just going to pick all the information. I know from our original version it's going to cross the axis at -5, so I've got that on. I know the discriminant is less than 0, so I know it's not going to cross the axis. I know that it's a negative quadratic because of the minus there, so I know it's got this N shape. So already I know it's going to come up through -5, it's going to come up here, but it's not going to get as far as the x-axis, so it's going to come back down again. So that tells me that my maximum point in this case is going to be somewhere in this quadrant here. And I know it's got a maximum at 2, -1. Now, technically speaking, the question didn't actually ask for that point, but I've got it in completed square form, so I've got that information, so I'm just going to put that on my sketch as well. So again, the maximum point is going to be where this thing is maximized, so when x is 2, that gives me a 0 inside the bracket, and that means the maximum point there will be at -1. So I know my maximum point on my curve is there, and so now I've got all the information I need to be able to draw the curve in, and there it goes. So there's my curve. That's that all sorted.